Okay. We have, yes, we have 7 business lines that is covering our engineering, inspection, calibration, testing, as a chemical testing and mechanical testing, non-destructive testing, certification, and training. Citadel Engineering Company has accreditation and certification from different ABs and CBs. Now, API is one of those ABs as CBs as a American Petroleum Institute that we received API Q2 and ISO 9001. We already have the ISO 17025 for calibration department, and regarding the quality, environmental and occupational health and safety, Citadel having their own certification. Okay, let's go and talk about the pressure relief valve, or PRVs. The function of the pressure relief valve is to protect pressure vessels, piping systems, and other equipment from pressure exceeding their design pressure by more than a fixed predetermined amount. The permissible amount of the overpressure is covered by various codes and is a function of a type of equipment and the condition causing the overpressure. The aim of a safety system is processing plant is to prevent damage to the equipment, avoid injury to personnel, and to eliminate any risk of compromising the welfare of the community at large and the environment. Proper sizing, selection, manufacturing, assembly, test, installation, and maintenance of a pressure relief valve are critical to obtaining the maximum protection. It's not the purpose of the pressure relief valve to control or regulate the pressure in a vessel or a system that valve protects. Then we have the pressure relief valve and we have pressure regulating valves. Pressure regulating valves are regulating the valve and regulating the pressure, but PSV and PRV, they're just actually when it's reached to the one certain amount that we call a set pressure, the pop-up action will happen, and then exceeding pressure will coming out either to the atmospheric or it's going back to the plant or the storage tank or the system. Now, let's say, as per the API code, what is the description of the pressure relief valve? A generic term for reclosing a spring-loaded pressure relief device, which is designed to open to relieve excess pressure unit normal condition until the normal condition, and then it's restored to the back pressure. Now, the device for the PRV is actually helping the system when it's over pressurized to back to the normal condition. Then there is no any concern about explosion or damage to the system. Design pressure. The value selected for the design of equipment for the most of severe condition of the coincident pressure and temperature expected in normal operation, with provision for a suitable margin above these operating conditions. To allow for operation of the pressure relief valve, the design pressure usually becomes the maximum allowable working pressure. Now, in the next slide, I will show you and we'll discuss about the design pressure. Then when you have one PSV or PRV, the range is between 20 to 50 bar, then 50 bar is maximum design pressure. And between 20 to 50, you can adjust the PRV or PSV to start working. Overpressure. A pressure increase over the set pressure of a pressure relief valve usually express a percentage of a set pressure compared with accumulation. Okay, pressure relief devices, PRD, are components used in refineries, chemical plants, and other similar facilities to prevent pressure vessels and other equipment from overpressurization by relieving excess pressure when necessary. They can be used release gas, steam liquids, or vapors. Properly functioning pressure relief devices are essential for protecting plant personnel and equipment. Since unexpected overpressure event can potentially cause equipment damage, loss of containment, and result in costly plant shutdown. Pressure relief devices include mechanisms such as a pressure safety valve, PSV, and pressure relief valve, PRV. Although there are other types of pressure devices as well, such as rupture disc devices and pin-actuated devices. These devices can come in many different sizes and shapes and allow pressurized fluids or gases to escape through a secondary passage out of the system, so that the pressure cannot build up beyond the safe operating limit. In the United States and many other country industries are required to use PRDs on the pressure vessels, piping, and other equipment. Several codes and standards that we will discuss also during this webinar are API RP 520, 521, 526, 527, 576, and ASME PD 583 and ISO 4126. Okay, what is the main difference between the PRV as a pressure relief valve and PSV as a pressure safety valve? Pressure relief valve is a generic term. It includes safety valves, relief valves, and safety relief valves. A PRV opens at the set pressure and closes at the reset pressure. Safety valve is a PRV actuating by the static pressure, resulting in a rapid opening. That what we call it in industry is pop action. Then usually PSVs are doing the pop-up. When they are reaching to the one set pressure, they are not, gradually release the pressure. Then with the one pop-up action, all the gas inside will coming out, and then it goes back to the reset. And mostly you have to remember that PSVs are using for the gas, vapor, and steam compressible media. This is what we commonly refer as a PSV. Okay, when a valve is referred to as a PRV, it could either mean that the relief valve is used for liquid, or it's a pressure relief valve in a generic sense and could be any type of the pressure relief valves. I would always look into the fluid in the pipeline if there is any confusion. Then mostly all our customers, when they are sending us one PSV or one PRV for calibration or testing, they're coming back to us with the medium. What kind of the medium it will be used for that pipeline or vessel. Pressure safety valve, PSV. A pressure safety valve is a type of a valve used to quickly release gases from the equipment in order to avoid overpressurization and potential process safety incidents. PSVs are activated automatically when pressure exceeds prescribed pressure limits in order to return equipment pressure to a safe operating level. Pressure relief valve is actually a type of the valve that used to release stored gas in various equipment in order to maintain an optimal pressure level. PRVs open gradually as the pressure builds up in order to release the necessary amount of the pressure. While the term PRV is sometimes used interchangeably with the PSV, there is a difference between two. A PRV open gradually, as I mentioned to you, and the PSV is open suddenly. Now, for most of the pressure vessels with the high pressure, and most in the refineries and the power plants, we are using the PSVs. This is the standard that we are following for sizing, selection, and installation of the pressure relief devices. There are some more standards that I want to show it to you. Okay, I just bring some of the standards that we are using in the industry for sizing, selection, testing, and choosing the PSVs. One of them is ISO 4126. Another one that this webinar is based on that is sizing, selection, and installation of the pressure relief devices, API 520. Inspection of the pressure relieving devices is API recommended practice, is RP 576. Some guidelines from the big manufacturing like Laser, Crosby, and safety devices for protection against excessive pressure, part 1 of the BSEN ISO 4126-1. Safety devices again for protection against excessive pressure, -3. ASME PTC 25-2014 is pressure relief devices. Seat tightness of the pressure relief valves. Flange steel pressure relief valves, that is API 526. Okay. Now there are some descriptions as per the standard that you need to know. The back pressure. The pressure that exists at the outlet of the pressure relief device as a result of the pressure in the discharge system. Back pressure is the sum of the superimposed and built up the back pressures. Blowdown. The difference between the set pressure and the closing pressure of a pressure relief valve expressed as a percentage of the set pressure in the pressure unit. Cold differential test pressure, or CDTP. The pressure at which a pressure relief valve is adjusted to open on a test stand. The CDTP includes correction for service conditions of a back pressure or temperature, or both. The set pressure. The inlet gauge pressure at which the pressure relief device is set to open under service conditions. One's test that is performed is to demonstrate that an individual valve will provide the capacity of a steam that is expected when the valve is called upon to relief. For each combination of valve and orifice size, valve design, and set pressure, there are to be 3 valves tested to measure their capacity. These capacity certification tests are done with the saturated steam at the flowing pressure using a greater of 3% or 2 psi over pressure. The requirement is that the measured capacity from any of these 3 valves must fall within a plus or minus 5% of the average capacity of the 3 valve test. That is one of the diagram that you can see and check how we are testing and calibrating the PRV or PSV. The most important part is that, as you can see, from 90 to 93%, we are testing as a leak test for the pressure. Then when one PRV or one PSV is coming for the test or calibration, you will testing that one with 90% of the set pressure. Now, when you reach to the 100%, is actually, we call it set pressure. Just I will try to show it to you here. Okay. Now, this is leak test pressure that usually we are going 90% of the set pressure. Okay. Now, from 100%, that is set pressure, the only thing you have just, and you can just 3% overpressure the PSV or PRV. Now, when the set pressure, it will reach, then the excessive gas or liquid will coming out, then blowdown usually is 4% to reach to that point. And then it will coming back to the reset pressure. Now, when you have kind of the valve, you will just do the test on the 100%. But before reaching the 100%, we have something that we call it cracking pressure. This cracking pressure, it means that it's not fully open, but there is some leak coming out. It means that the spring inside the PSV or PRV is under pressure. And you will find out that, okay, the setting pressure is going to start soon. Type, design, and construction a pressure relief valve must be capable of operating at all times, especially during a period of power failure. Therefore, the sole source of a power for the pressure relief valve is the process fluid. The standard design safety valve is spring-loaded with an adjusting ring for obtaining the proper blowdown and is available with many optional accessories and design features. The bellows and balance bellows design isolate the process fluid from the bonnet, the spring, the steam, and the steam bushing with the bellows element. Jacketed valve bodies are available for application requiring steam or heat transfer medium to maintain viscosity or prevent freezing. Now, I just bring it some figure from the standard that you can just find out how this PSVs and PRV is going to work. First of all, this outlet can connect it to the atmosphere. It means that when the set pressure is reaching to that point, the excessive gas is coming to the atmosphere, or it will be connected to the one pipe and is going back to the system. Then if it's connecting to the system, then you have the back pressure. Okay, now from here, the medium is pushing the PSVs and you have the spring that is here, and then you have the disc and the nozzle. Okay, now when it's reaching to the set pressure, it's actually this disc means that the force of the gas or liquid is more than the surface and the spring, and it will be open, and the excessive gas is going out from here. That is how the PSV is working. For this type that you're seeing right now in front of you is conventional PRV with a single adjusting ring. This is single adjusting ring. That how, from the first slide, I told you if the range is from 20 to 50 bar, you can adjust it with the adjusting screw to reach to the desired pressure. This one is balanced below PRVs. As you can see, is exactly the same conventional, but you have one bellows right here, this side, that is supporting disc for doing the job. This side, again, is balanced bellows, PRV, with auxiliary balance piston. Then this one also is going to support, again, with another piston. Each one of them will be used on the different medium, different processes on different locations. We have also this conventional PRV with thread connections that you can see. Okay, and we have also some type of valves like pilot valves that I will show the photos in the next slides. The codes and the standards. Section 1 of the power boilers of the ASME standard, ASME, is Section 3, division for nuclear power plants components. Section 4 of the heating boilers. Section 6 for the recommended rules for the care and operation of the heating boilers. Section 7 is recommended rules for the care of the power boilers. And Section 8 is Division 1 for the pressure vessels. ASME specifically states in Section 8, Division 1, paragraph UG 125A, all pressure vessels within the scope of this division, irrespective of the size of a pressure, shall be provided with the pressure relief devices in accordance with the requirements of the UG 125 through UG 137. By 1911, it was apparent to manufacturer and user of boilers and pressure vessels that the lack of uniformity in this regulation between the states made it difficult to construction companies. A group of disinterested I think it's disconnected, but let me just check it out. Okay, I think there was a problem from our side. Now we're coming back to normal. Okay. Yeah, now some of the manufacturer, they have to get the accreditation and certificate from, we call it AIA, as an authorized inspection agency that they are already certified by ASME. And based on that, they can certify the factories to gain the UV stamp. Okay, before we discuss about the equation nomenclature, I want to show you one video about the very small PSV. Okay. The one that you're seeing is actually one reference gauge, we call it test gauge on the pressure bench test. And as you can see, the accuracy of the gauge is very high. And currently, this one is going to be tested with, if I'm not mistaken, it's 11 bar. Now, what you can see, on the 10, it starts some cracking. Then you have some leak in between. Now, when the pressure is reaching to the set pressure, that is 11, you cannot go more than that. Otherwise, if you have too much flow. Otherwise, it will not go more than 11 bar because the set pressure is on 11 and the valve will be open on that. Now, when you stop pressurizing, this is what I'm telling you that we call it reset pressure. Then it's going back to reach to that. Okay. Now, let's say what a standard is telling for the equation. We have Kw as a correction factor due to back pressure for use with the balanced bellows valve. M is molecular weight, P1 is upstream pressure, P is differential pressure, Q is flow, GPPM, and RNE is Reynolds number, W is flow, P is liquid dynamic, absolute viscosity, and KV is correction factor for viscosity. All these areas are coming to the API standard, and when you want to order one safety valve, all those information are available on the manufacturer website that you can see, and you can choose the valve based on your requirements. Okay. Each piece of the equipment in the process should be evaluated for a potential overpressure scenarios. An appropriate design basis must be established for each vessel. Choosing a design basis requires assessing alternative scenarios to find the credible worst case scenarios. The design basis is then used to calculate the required pressure relief valve size. If possible, the sizing calculation should use the most current methodologies, incorporating such consideration as two-phase flow and reaction heat resources. Determination of the worst-case controlling scenarios as process plants become larger and are operated closer to safety limit, a systematic approach to safety becomes a necessity. Determination of the set point pressure. Process equipment should be designed for a pressure sufficiently higher than the actual working pressure to allow for the pressure fluctuation and normal operating pressure peaks. This is some of the PSVs that you can find out, conventional type, and on the right side, you can see the pilot valve. This type, mostly they are using for the liquid type and the gases, both of them. And there is no spring inside it. Then with the help of the medium that's coming for the backside, they will adjust the set pressure and they will get that one as a source for activating the pressure. Okay, going back for the back pressure again, As I discussed, the back pressure in the downstream piping effect the standard type of the pressure relief valve. Variable built-up back pressure should not be permitted exceed 10% of the valve set pressure. Then, if you have a back pressure, let's say on the atmospheric is 1 bar, then you're installing 1 PSV on the top of the tank. You have to consider that 1 bar as a back pressure. Then when you are doing the set pressure, for example, 10 bar, you have to consider that the valve will not be open on the 10 bar because you already have a 1 bar back pressure. Then this variable back pressure exerts its force on the top side of the disc holder over an area approximately equal to the seat area. This force plus the force of the valve spring when greater than the kinetic force of the discharge flow will cause the valve to close. The valve then pops open as a static pressure increase, only to close again. As this cycle is repeated, severe chattering may result with consequent damage to the valve. Now, when you see on the photos, you have the back pressure from the outlet that is pushing the seat down. And that is how you should determine and calculate the back pressure. Overpressure consideration. Overpressure consideration, back pressure correction factor, should not be confused with the correction factor of the KP that accounts for the variation in relieving capacity of the relief valve in liquid service that occurs with the change in the amount of the overpressure or accumulation. Typical values of the KP range from 0.3 for an overpressure of 0%, 1 for 25%, and 1.5 for an overpressure of 50%. A regression analysis on a typical manufacturer performance data produced the following correction equation for the KP. Now, when you finish the pressure, set pressure that you need and the pressure that you want to work with, you have to rate of the relief valve to see what orifice area you need. The required size of the pressure relief valve orifice or the effective area can be determined by the table of the API that I just copied here, and it's available on API 521 as well. Sizing formula in this course can be used to calculate the required effective area of a pressure relief valve that will flow the required volume of a system fluid at anticipated relieving condition. Also, when you're selecting and sizing your PSV or PRV, you have to see the inlet and outlet piping. Now, why is important? Satisfactory operation of a pressure relief valve requires that it be mounted vertically, preferably on a nozzle at the top of the vessel, or on the T connection on the top of the pipeline. The minimum inlet piping size should be equal in size to pressure relief valve. The length should be minimized to reduce pressure drop and bending moments resulting from the reaction thrust developed from the discharging fluid. A rule of thumb is to design the inlet piping such that the total pressure drop in the inlet piping does not exceed 3% of the set pressure. Now, if you want to make from the vessel, you have to connect or hot tapping one kind of the PRV or PSV. You cannot get the length, for example, 1 foot or 1 meter because you have the drop pressure, and then your PRVs become useless. Viscous fluid consideration. This is also very important. Then for different products, different material, different medium, you have to consider that this one is affecting on your calculation. The procedure to follow to correct for a viscous fluid is determine the preliminary required pressure relief valve orifice size that I discussed with you. Use the actual area of the viscous trial size orifice to calculate the Reynolds number, and use the Reynolds number calculated in step 2. This is kind of the PRV. As you can see, it's coming back to us for repair and maintenance, and When we open, we find out that the spring was completely damaged. Now, if this spring is not pushing the seat down, it means that the pressure PSV or PRV is not working very well. This is another type of the valve that mostly it will be used on the top of the storage tanks, fixed roof. This is, as you can see two type of the valves. This is one PRV, and this one, we call it PVRV, pressure vacuum relieving valve, that it will be again on the top of the storage tanks, and they're going to be ready to for the safety valve container for bench testing. Okay, the summary is any safety relief system is subject to certain conditions that are the principles basis for the design. Determination of the correct required relieving capacity is oftentimes the most aptest step in the design process. Then it's very important for you to follow the same steps to calculate and design for the pressure relief devices that you are going to use. Pressure relief valves should be designed to passively protect against a predetermined set of the worst case condition and should be installed to react to these conditions regardless of the daily operation activities. That was it. Actually, we were thinking 45 minutes it will take time to finish this webinar, and we hit the target. Now, we are ready if you have any question. Thank you.
Thank you, Shahriar, and thank you everybody for sitting at this webinar. We are open and we are listening to question. If anyone has a question, please go ahead and ask either in the chat or I can unmute you and you can just ask your question. Okay, there is a question someone asked that how we can test a PSV. Mr. Shahriar, would you please kindly provide the answer to this question?
Okay, for testing or calibration of the PSV or PRVs, depending on the medium that you're using, if it is liquid or the gas or steam, you have to testing with the water or nitrogen or steam. Now, as I discussed in the slide, and the test need to be done as per the API 571 and 526, and you have to do the test 3 times with the set pressure, and you have to check the seat tightness test as well. Then, as we discussed, between 90 to 93%, you have to pressurize the PSVs and see that the leaking is as per the standards or not.
Okay, I believe Ravand has a question. Ravand, I'm gonna unmute you and you can go ahead and ask your question or just type it here in the chat area.
That is the question that Ravand asked. Where most common are that we use the PRV in production of the gas side? Okay, yes, for the gas plants and power plants that the GTs are working on the natural gas, they are using it on a lot of areas. Then that is one of them is. One of them is on the pipeline or piping that we will use the PRV. Another one that there's fan coolers and the vessels inside the plant that we are going to use the PSVs and PRVs on top of them.
Thank you, Shahriar. There is another question. Mr. Stefan is asking, does altitude affect set pressure, and how often valves should be tested?
Say, if we are just moving the PSV and the height is too much, yes, that is why we have the back pressure. We have to calculate the back pressure, and definitely it's something that you need to calculate it. And depends on the standards and depends on the plant or customer regulations. Usually they are checking and testing the PSVs from 3 months to 2 years, depending that what is their integrity procedure is based on.
Thank you, Shahriar. We are open to receive your question for 10 more minutes, and then we have to say goodbye to everybody. So please go ahead if you have any questions. Otherwise, we will end the webinar like right here and say goodbye to everybody. Please, we are waiting to receive your questions. Yes, thank you, everybody. So I think there is no more questions here. I hope a very good day for everybody, and I hope that everybody gets some new information and new knowledge out of this webinar. Your certificates will be sent to you by the provided email address when you signed up for this webinar. Have a very good day, and see you in the next webinar, hopefully. Bye.